The large ball of fire thousands of miles away from us is the brightest object in our solar system, as well as the biggest. If Jupiter was the size of a basketball, then the Earth would look like a tiny little grape. But the Sun makes even Jupiter look like a joke. That big burning ball in the sky is made up of hydrogen and helium, and is 864,000 miles in diameter, making it more than 100 times wider than our little blue planet. It's 10,000 degrees Fahrenheit just on the surface, and 27 million degrees at the core. The Moon, on the other hand, is a little easier to grasp at around 2,160 miles in diameter, which is only less than a third of Earth. It might seem pretty big floating in the sky, but that's because it's the closest object to us. But what if the tables, or in this case, celestial bodies, have turned, and the Moon suddenly became brighter than the Sun? Let's explore several scenarios. Scenario 1. If the Moon becomes brighter than the Sun, the nights will be brighter than days. It means your sleep cycle will be disrupted. All nocturnal animals will be utterly confused. When is it time to go out and eat now? In the extreme north and south poles, the nights and days are for months on end. So people living in the area already have an idea of what it's like to sleep at 11 p.m. with the sun shining brightly above them. For the rest of us, it won't be easy. Let's say you're out camping and prepare an awesome meal and gear up for the dark nights. As you trek into the forest, you find a spot that has an awesome view of the lake and the clear sky above. It's 7 p.m. and you start a fire for some s'mores and get the telescope ready. The only problem is that when the sun begins to set, the moon lights up the sky even brighter. It's surprisingly not as hot as you'd imagine, since it's not direct sunlight, but regardless, it's still pretty hot. Scenario 2. Temperatures will surely rise either way. That means snow will melt away faster than you can go, What's going on? The snow on the mountains will be the first to melt, followed by the polar caps. With so much heat, the sea levels will rise and take small remote islands scattered across the ocean underwater. Coastal towns will go down and everyone will live closer inward. This will likely cause a chain reaction in the world economy. There will be no more winters, which means no more winter activities like skiing, snowboarding, or snow fights. Animals and plants all around the world will be affected. The world will turn into a large desert. Water will get scarce over the years, but people will find a way to preserve it. Scenario 3. You're sitting behind your desk, bored. You're losing business. People aren't buying as many sunglasses as you thought. But when the moon suddenly becomes brighter than the sun, and everyone needs to wear those glasses 24/7 when heading outside, you can't keep up with the demand for sunglasses, so you hire more people and grow your business. You eventually become the best sunglasses business in the country. They don't recommend looking up at the sky at any point of the day or night. Cities are covered with large visors to reduce the brightness every day. Sunglasses will come in different sizes and shapes for different times of the day. Some will be like goggles strapped around your head, while others will be like large helmets. Scenario 4. The moon's atmosphere is so thin that it can't contain anything in it. Just like over deserts on Earth, there are no clouds to bring some rain, which is why it's always hot or cold. Yeah, the biggest desert in the world is the whole continent of Antarctica, which is a cold, barren desert, contrary to what people think of the Sahara Desert. So if you still want to land on the moon, you better think twice now. People who are working at the International Space Station will have to find a new office. The moon will be too bright to bear, considering how close they are. If the moon is just brighter than the sun without the heat part, then the space station will only require adjustments to keep the light out. The reason why we see the moon in various shapes is because of its position in relation to the sun. The moon doesn't rotate, unlike Earth. It's kinda glued to us and is always showing the same side. So, depending on the moon's position during the month, we'll have a super bright night during the full moon, and relatively shiny nights during the rest of the month. Scenario 5. If the moon became brighter than the sun, it would produce more heat than the sun and probably become larger. Gravity on Earth would change significantly because of the moon's new size. The whole orbit structure would change and affect the celestial objects floating in space. Planets would soon begin to orbit around the moon, Earth might move further away from the sun. If that happened, then everything would have to readjust to the radical changes in gravity. Weak gravity means buildings wouldn't have a solid foundation to sit on and would eventually collapse. Bridges and large monuments would also fail to hold up. People wouldn't be able to walk properly and would do it in a funny way. Scenario 6. In many of these scenarios, I mentioned how the moon would be brighter than the object emitting light, but in this case, the sun would have to come from the moon reflecting from the sun, which means that the sun would have to be twice as bright as it is now. If the sun got 100 times bigger, it would shoot out more rays, which can be damaging and throw off a lot of radiation, harmful to every living thing on Earth. The gravitational pull of the sun might attract more planets to orbit around it and cause other objects in space to join the orbit. The planets would be partying in our galaxy club, and we might be thrown off our orbit course. Of course, this would pose a bigger risk to everything on Earth as things would get hotter and drier than before. Scenario 7. If we're talking about the moon getting brighter, we can also assume it would get closer to Earth than it is now. The brightness won't be the problem here, as gravity will cause major changes on Earth. But every day, 24/7 will be high tide. It will be so extreme that there will be constant floods in every coastal town. All islands will be submerged, which will increase the population of inland cities. Marine life will be having the time of its life when water overtakes the land. Boats will have to be re-engineered for new conditions as well as submarines. Air travel will be the priority, but large cruise ships will look futuristic and have an extra build to sustain the harsh waves. Nighttime will be pretty bright on regular days. It will raise the global temperature, which will melt down the snow, causing the sea levels to increase even more. Comets and other celestial objects will be drawn to a closer gravitational pull, so we will always have to look up whenever we go outside. But no worries, the moon is still up there as it is for a very long time. The Earth and the moon's relationship is complicated. Luckily, we only have one natural satellite. Other planets in our solar system have multiple moons revolving around them. Some are so huge that they're the size of Earth. Imagine several of those affecting our home, but that's a topic for a completely different story. It's dark outside, almost 2 a.m. You go outside and look at the sky, and here it is, bright, full moon. You might think you know a lot about Earth's natural satellite, but let me ask you this: how did it form? The answer is, nobody knows. But of course, there are theories. The most popular one, called the giant impact theory, claims that the moon formed during a collision between Earth and another planet. This planet must have been smaller than ours, the size of Mars, and the collision itself probably happened around 4.5 billion years ago. Another theory, called the capture theory, claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. But here is one catch. Our planet and the moon have remarkable isotopic and chemical similarities. So, they must have a linked history, which means the moon couldn't have been created elsewhere. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet. That's how the moon appeared in the sky. But again, there's one problem. In this case, the proportion and type of minerals on the moon would have to be the same as on Earth. But there are slight differences. The moon is richer in materials that form very fast at high temperatures. There's one more theory, and it's probably the least exciting. It claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. Duh! But these days, a more urgent question keeps astronomers busy. Is the moon really Earth's satellite? Or are these two twin planets? The moon is big compared to our planet, about 1/4 of Earth's size. That's why some experts refer to our planetary system as a double planet. But how correct is that? If we want to figure it out, we need to give the definition to the word planet. According to the International Astronomical Union, a planet is a space body that orbits the sun. is massive enough to have a nearly round shape thanks to its gravity and has cleared the region around its orbit. Now, what about a satellite? It's an object in space that orbits around a larger celestial body. If we take the system Earth, the Moon, its center of gravity, called a barycenter, is inside the Earth. That's why at the moment we can't say that we live in a twin planet system. According to this definition, the Moon is the satellite of our planet. Now, let's get back to the past, like 3 or 4 billion years ago. Even though the Moon wasn't a planet, it most likely had a full-fledged atmosphere. It formed at times when powerful volcanic eruptions were rocking our satellite. Gases spread all over the Moon's surface, and it happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurtling high into the air, falling to the ground and creating lava flows. That's how the basalt basins appeared on the surface of the Moon. At one point, scientists got their hands on samples brought from the Moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the Moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggests the Moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days our satellite is around 240,000 miles away. That's why the Moon looked much, much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. These days, the atmosphere of the Moon is almost non-existent, and that's why the satellite can't protect itself from meteorites. The surface of the Moon is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the Moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. And since the Moon is less seismically active than Earth, these craters and other ancient formations stay in perfect condition for centuries. When you look at the Moon, it's the brightest object in the night sky. But in reality, its surface is dark because the reflectance of our natural satellite is just a bit higher than that of asphalt. You might know that the Moon's gravitational pull causes tides on our planet, making the oceans bulge out on both the side closest to the Moon and the one farthest from the satellite. But that's not all. The Moon also slows down Earth's rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The Moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. If one day the Moon floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the Moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Even though the Moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. One theory suggests that they may be happening because the Moon is shrinking as its insides are cooling. Scientists say that the Moon has become around 150 feet skinnier than it used to be several hundred million years ago. To help you understand it, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the Moon. It's shrinking and it's wrinkling. But unlike the grape, the Moon doesn't have flexible skin. Its surface is hard and brittle, so as the Moon gets smaller, the crust cracks and breaks, and its sections get pushed over neighboring parts. Want to know another cool thing about the Moon? A recent study claims that it has a tail. and every month it wraps around our planet like a scarf. This slender tail is made up of millions of atoms of sodium, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. And the spiciest fact for you, 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it was no larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet, called 2020 CD3. It was our temporary mini-moon. It didn't stay with Earth for long, though. The asteroid followed a random orbit and slowly drifted away. Temporarily captured objects such as 2020 CD3 are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction.
Neil Armstrong had been getting ready for his mission on the moon for over 3 years. To resist microgravity conditions, he had to learn how to walk sideways by being strapped and suspended at an angle in trying to walk along walls. His limits were tested through an intense diet and sleep regimen, since in space he would only have beef and vegetables, previously dehydrated and stuffed into a package. Back in the day, astronauts had to experience the desert, jungle, open sea, and Arctic survival training. These days it's a lot more structured, but back then it was more of a let's drop this person in the middle of nowhere with no supplies and see if they make it. Before landing on the moon, he had to gather and study rock samples in the Grand Canyon, explore ancient volcano formations in the Nevada National Security Site, and look into gas and lava vents, lava lakes, and pit craters in various locations in Hawaii. On July 20th, 1969, Armstrong was given a hearty breakfast before blastoff. Steak, eggs, toast, juice, and coffee. He received what doctors call a low-residue meal, which means he wouldn't have to go to the bathroom soon after. It took him 109 hours and 42 minutes to reach the surface of the moon, in an area called the Sea of Tranquility. He had to travel 240,000 miles to get there. The crew could have gone for the Ocean of Storms or the Central Bay, but this place was chosen for landing because it had good visibility, was relatively smooth, and was easily reachable with as little propellant as possible. When he was at about 500 feet above the surface of the moon, Armstrong had to maneuver the spacecraft manually to make sure they wouldn't land in a dangerous crater. He continued to hover for about a minute and a half, moving it sideways until he felt comfortable to land. As soon as his device landed safely, he immediately radioed to Mission Control, located in Houston, Texas. The now famous message,
"The Eagle has landed."
Steadily, he went down the lunar module's ladder, while a television camera was attached to the craft to record his progress. The camera also transmitted the signal back to Earth, where hundreds of millions of people were anxiously waiting. At precisely 10:56 p.m. EDT on the same day, Armstrong placed his feet onto the lunar soil, saying,
"It's one small step for man, one giant leap for mankind."
The schedule said that the astronaut needed to sleep before the first moonwalk, but he chose to go outside earlier than planned, since he obviously couldn't sleep. If Armstrong had walked on the moon without special equipment to breathe, he would have smelled a weird odor, sort of musty and sulfuric. Still, he had the chance to smell it when he returned to the lunar module. The thing is, the dirt had clung to his feet, so the odor spread all over the cabin. He described it as wet fireplace ashes, or how the air smells after fireworks shows. Who would have thought you needed to pack a scented candle when going to the moon? Apart from the people that have since made it to the moon, no one ever got the chance to know precisely what the crew was smelling. Even during that first mission, when moon soil and rock samples were transported to labs in airtight containers, once they were opened back on Earth, surprisingly, the smell was gone. He also felt the surface of the moon to be fine and powdery, but said he had no difficulty in moving around. One other member of his crew joined him about 20 minutes later. The whole moonwalk took a little over 2 hours. During this time, Armstrong and his teammates set up various devices on the surface of our satellite. One was meant to precisely measure the exact distance from there to Earth, by timing how long it took for a laser beam to travel from Earth to the lunar surface and back. Another meant to measure moonquakes and potential meteor impacts, which leads us to the discovery that the moon was pretty alive after all. We know today that the largest moonquakes are much weaker than the largest earthquakes, though their movements can last for up to an hour, way longer than on Earth. They managed to gather somewhere around 50 pounds of rock and soil samples. They also snapped many photographs of the terrain, where they also planted a US flag. The astronaut even got the chance to catch up with President Richard Nixon, for less than a minute though. The final thing on the list for Armstrong was to go for a walk to what is now known as East Crater, 65 yards east of the lunar module. It was the greatest distance traveled from the spacecraft on that specific mission, approximately the length of half a football field. As soon as his tasks were done, Armstrong went back into the lunar module and safely closed the hatch to get some sleep. While preparing for liftoff, Armstrong and his crew discovered that, because of their chunky spacesuits, they managed to break the ignition switch for the ascent engine. No big deal, they thought. So they used a part of a pen to push in the circuit breaker to start the launch sequence. At 1:54 p.m., the famous Eagle began to ascend. Apart from the scientific equipment installed on the surface of the moon, a plaque was also left there. It read, "Here, men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all mankind." Years later, Armstrong said that NASA limited their time on the moon because they didn't know how the spacesuits would handle the moon's extreme temperatures, as high as 260 degrees Fahrenheit during the day, to as low as 280 degrees Fahrenheit below zero at night. Things got a bit more complicated when Armstrong landed back on Earth, since he had been exposed to unknown space particles. The result? He and his team had to be placed in planetary protection quarantine on their return, as soon as their space capsule safely splashed down in the Pacific Ocean on July 24th. That specific quarantine for the Apollo 11 astronauts is one of the reasons why we have microwaves in our kitchens today. When they first returned from the moon, they initially spent their first few days in a mobile quarantine facility, or MQF. Sure, the MQF featured comfortable chairs, bunks, a toilet, and showers, but it didn't leave a lot of space for fancy cooking. Since there was no room for a standard oven or grill, and to also reduce the potential fires that might have occurred, NASA had to get creative. That's how the original countertop microwave oven was developed, to easily help astronauts get their meals without the hustle of a fully equipped kitchen. These days, you can see that first microwave in a museum in Oakland, California. After returning to Earth, Armstrong claimed he would never reach for the stars again. But he didn't stop exploring, though. Back in 1985, he joined a professional team of other greatest explorers to the North Pole. He was joined by mountaineer Edmund Hillary, aviator Steve Fawcett, and photographer Patrick Morrow, reaching the pole on April 6, 1985. Armstrong claimed he wanted to see what the Earth's icy pole looked like from the ground, since he had only seen it from the surface of the moon. The Apollo 11 mission was nevertheless unforgettable for Armstrong since. In 2015, the Smithsonian Institution uncovered that he had kept hidden a cloth bag full of small parts from the lunar module. It included his waist tether, some utility lights, and their brackets, an emergency wrench in the optical sight that was mounted above Armstrong's window of the space module. It also contained the data acquisition camera that recorded the iconic footage of Armstrong taking his small step on the moon. Armstrong kept it to himself for many years until his widow, Carol, eventually found it. He even kept it a secret from his official biographer, who had many times asked if he had kept any memorabilia from his famous mission. He didn't sneak those objects back on Earth, though. He just mentioned it to be a bunch of trash he wanted to bring back.